Good afternoon and welcome back to Dr. Logic Awkwardly Does Logic in the Sunshine. It's wonderful. We've got one final rule left in the proof theory for predicate logic, and that is the rule for eliminating an existential. Now, this one can be somewhat complicated to actually give the definition and the schematic drawing for, but the idea behind it is quite straightforward. The idea is if you have a sentence that says, there is something that has some particular property, then you can make an internal assumption and essentially give a name to that object. So if I say there is something that is blue, then you can say, assume that thing is called Fred. Then, whatever you can derive from that assumption, so the assumption that gives a name to the thing that to the existential that you're trying to eliminate, whatever you can prove from that, if you can prove something that doesn't use that name, so if you can go from, I'm not going to try to give an example off the top of my head because it probably wouldn't make any sense. Once I've defined the rule, I'll give you some examples so you can see. But the idea is that you pick a name for the thing that you know exists, and then you derive some other general statement not discussing that name at all. And then you can say, okay, because it doesn't matter that I called it Fred, then what I've derived from this, I can bring outside of my assumption and conclude that as an elimination of the existential. So this rule is not quite as straightforward as the other ones, in part because, like disjunction elimination, it's not really clear how you're eliminating the disjunction because you might end up with a disjunction at the end. Just like if you're eliminating an existential, you might end up proving an existential. But the idea is that you are moving from something that has that as its main connective to something else. So it's in that sense that you are eliminating the existential. So with all of that in place, let's go ahead and I'll give you the formal definition of the rule. So, rule, this is existential elimination. And like universal introduction, it's going to have a couple of provisos that you will have to pay attention to every single time that you try to apply this rule. So I will flag these up and belabor them at great length because they are important. So this rule says if you have something of the form exists x phi on line I of your proof, where I is less than n, as it always is, and if psi can be derived from the assumption of phi with tau replaced, tau substituted in for all free occurrences of x. So I've taken away the quantifier and then I've done this substitution. So if I assume this on line j, again, where I comes before j and j comes before n, and then here's the important proviso, has to be the case where tau is a term, two things. One, it doesn't occur in psi, or in any assumption on which psi depends, except the one that you made at line j. So except the assumption on line j. This proviso is to ensure that you have picked an arbitrary name, that the name that you picked for your object didn't play any role in what you were able to derive from that assumption. So the easiest way to ensure you meet this proviso is just pick a new name. Pick something that you haven't used before in any of your previous assumptions. That way, the only place that it will appear is in the assumption at line J, and then you just need to check that the formula you are deriving it doesn't mention the constant that you have introduced. So if you've got all of this going on, then you can terminate the scope line that J introduced at line n-1, and then you can write psi on line n with annotation existential elimination, and then you cite line I, which is where the which is where your existential statement occurred, and then lines J to n-1, which is the subproof that you will then close off with the citation of this rule. So schematically, what this looks like is, so you've got your proof, you've got various premises, you've got various other things, and then here at line I, you've got something of the form exists x phi. And then at some point later on, you say, okay, I'm going to call that object tau. Oops, that should be an x. There we go. So I'm making a new assumption. Then at some point later on, some line n-1, I can derive psi. Now, I don't know how. This is left open. It's not prescribed by this rule, but we'll apply some other rules so that we get some annotation here. But then I need to check, does tau A only occur in J, not occur in psi, and not occur in any assumption earlier in the proof? If so, then at line n, I can write down psi, and we have existential elimination, line I, and line J to n-1. So this is somewhat more complicated than the other rules, but it's not any more complicated than universal introduction. It's got the same sort of check that you're not doing something illicit with your constants requirements. So we've got, oops, I wanted a different color so I can express this explicitly. So first, you need to check that the constant doesn't occur in psi, and then you need to check that it doesn't occur in any assumption on which psi depends on, except the one in which you introduced it. Once you've done that, then you can apply the rule and you're done. You're safe. So there you have it. You now have all of the new rules that you need for doing predicate logic proofs. You've got the rules for identity, reflexivity, symmetry, transitivity, and substitution of identicals. You've got introduction and elimination rules for each of the quantifiers, and you have quantifier interchange. That's it. With these rules and the propositional rules that we studied some months back, you've got everything that you need to prove anything you would like to prove. In the next videos, I'll start going through some examples so that you can see this. First, just generally kind of putting bits together, how do the rules work, seeing them in action, and then we can kind of extrapolate from our experiences and talk about general proof strategies and how to extend the proof strategies that we had for propositional logic to predicate logic. So that's it for now. I look forward to seeing you again soon. Cheers.